Welcome to solverfy.
Okay, we're told that we have a molecule with the formula C7H6NO minus. It's a molecular anion having the overall charge -1, but we're also told that that -1 charge is on nitrogen, and we're given the skeleton for the molecule. But we're not given where any of the hydrogens are, what any double bonds may be, etc., etc. Other than that, we have a negative charge on nitrogen there. Okay, and what we need to do is add all the hydrogens. We need to add lone pairs or valence electrons, and we need to add pi bonds. Okay. Now, one thing that you'll recognize based on the fact that we have 7 carbons and only 6 hydrogens is that we must have a good number of double bonds. Right? Recall that the typical formula for an alkane that has no double bonds or triple bonds or rings is that you'd have C7H, then you'd have 2 times 7 plus 2, or C7H 16, right? We have 10 less hydrogens than we would expect based on that formula, which means that we should expect to have 5 rings and double bonds. Right? Each time you add a ring or a double bond to a structure, you lose 2 hydrogens. And so if we have 10 less hydrogens than you would expect based on the 2n plus 2 formula, then we know we have 5 rings and double bond. Well, one ring has been shown to us in the formula, but we can pretty much safely assume that this must be benzene, right? That would take care of, for example, one additional set of, or 3 additional rings and double bonds, which means we have hydrogens here. All right, so there's 5 of our hydrogens. We have 1 left. Okay, we also have 1 double bond left. Right, so we have 1 hydrogen and 1 double bond left. So we could, the only places we can add double bonds at this point would be a double bond to oxygen and adding a hydrogen to nitrogen, or adding a double bond to nitrogen and a hydrogen to and an oxygen to hydrogen. As it turns out, if we have a negative charge on nitrogen, we would not expect it to be sp2 hybridized. A neutral oxygen is much more likely to be sp2 hybridized than an sp2 than a negatively charged nitrogen, which means that the double bond must be to oxygen, the hydrogen must be on nitrogen, that's our 6 hydrogen, and now, based on the fact that nitrogen has 2 bonds and a negative charge, we know that it must have 2 lone pairs. So that is the final structure. I could draw it a little more cleanly down below, mostly just in terms of the way that nitrogen looks, because when you go to enter this into a online system, sometimes you need the geometry to be just right. So we're going to have your benzene ring, alternating double bonds. You can have your hydrogens. You're going to have your double bond to oxygen here, single bond to nitrogen, single bond to hydrogen, lone pair above, and a lone pair to the right, and a negative charge.